Welcome to EPG Pathshala lecture series in computer science. This course is on operating systems. This module will continue to learn about file systems. We will continue to learn from where we had left in the previous module. The learning objectives of this module are we need to understand the structure of a disk. We need to discuss file system design like directory structures. So, when you are looking at systems, they store millions of files on disk. So, it is not that a disk will have only a single file, there will be a lot of information that is stored in disks. So, it is necessary to organize, to manage this large number of files. The files have to be organized in a proper manner. So, for that the disk, which can be in terabyte size, can be divided into multiple divisions called partitions, and the disk partition can be used as a raw partition, or it can be divided into partitions, and you can place file systems in the partitions, or the disk can be used as such without any file systems. The partitions of the disk, they are also called as mini disks or as slices. And when you consider one particular disk, each disk has at least one partition, and it is possible to store partitions, it is possible to store multiple operating systems in partitions. That is, each partition can have a different operating system, and this entity containing the file system is known as a volume. And so, each volume will have a file system, and hence it is also necessary to track the file system's information. So, each volume will have a device directory or a volume table of contents. This device directory or volume table of contents will give details about the different files that are placed in the file system that is present in that particular volume. So, this device directory will record information like the name, the location, the size, the type of all the files that are kept in that volume. So, here this diagram shows a typical file system organization. Like, see here you can see that in one disk there are two partitions, partition A and partition B. In partition A, you have a directory which gives details about the different files that are placed in this partition. Partition B can have another file system which also has a directory which gives details about all the files that are kept in this partition. It is also possible for one file system to span across two different disks or multiple disks. So, here you can see that there is a partition that spans two disks, disk 2 and disk 3, and there is a directory that gives details about the files that are placed in this partition. So, what is this directory? We need to now learn about this directory structure, the different ways in which the directory structure can be maintained. So, first we will see what this directory structure is. This directory structure, as I told you, is a collection of nodes containing information about all the files that are kept in the file system. Both the directory structure and the files reside in the disk. So, disk has got partitions, the partition has got file systems, and the file system has got different files, and information about files are stored in the directory structures. And these backup of these two structures, the directory structures and the files, they are all kept in the tapes. Now, we will see what different operations can be performed on a directory. So, when you have directories that have details about the different files, it should be possible to perform different operations on directories. So, one operation is to search for a file. As we saw in the previous module, the directory has got information about all the files present in that particular directory. So, if you need to search for a file, you need to search into the directory. So, this is an operation that should be possible to be performed on a directory, and then creating a file. So, for creating a file, an entry has to be created in the directory. So, it should be possible to create a new entry in the directory, which means you need to write into the directory, you need to write the file's name, you need to write details about the file into the directory. So, creation of a file will need write permissions into the directory. Then deleting a file. So, when a file is deleted from a directory, it should be possible to remove the name of the file from the directory and all details from the directory, which again will need write permissions in the directory. Then listing the contents of a directory. So, if you need to know which are all the files that are present in a directory, then it should be possible to list the contents of a directory. Then renaming a file. So, suppose if you need to change the contents of a file, and based on that you may want to rename the file, and then in that case it should be possible to change the name of the file, and while changing the name of the file it may be possible that the position of that file in the directory may get changed. Then traversing the file system. So, traversing the file system, for traversing the file system you need to have permissions to operate on the directory. So, the directory again has to be organized logically properly, so that all these parameters are achieved. One is the efficiency, that is, it is efficient if you are able to locate a file quickly. So, as we saw earlier, we need to be able to search into a directory, to list the contents of a directory, etc., and so on. So, when you are trying to search for a file in a particular directory, you should be able to locate the file very quickly. So, the search should be efficient. And then naming of files. So, you can't just give arbitrary names to files. If arbitrary names are given to files, then understanding what the contents of the file are just from the file name will become difficult. So, it is necessary to name the file which is convenient to the users. And it is also possible that two users can have the same name for different files. So, that should not be allowed. So, if two users are using the same name, but they can be different files, two different files should not be given the same name. And it is also possible that the same file can have several different names depending on who is using the file and so on. So, this naming convention has to be taken care of to organize the directory properly. And the next is grouping of files. So, based on the type of the file, based on the properties of files, you need to logically group the files. Say for example, say you write say C programs as well as Java programs, then you may want all the C programs to be put under one particular directory, and then all other Java programs to be put under another directory, or maybe you can have some games which has been put under another directory and so on. So, logically you can group similar types of files which are logically similar into a particular directory, so that it will be easier to access, easier to know which files are present where. Now, we will see the different ways in which the directory structure can be implemented. So, the simplest of all different types of directory structures is to go for this single level directory. In single level directory, there is a single directory for all the users. So, you can see here that there is a single directory which is maintained for all the users. So, the files of all the users will be kept under this one single directory. But the limitations of this mechanism or this kind of a structure is that when the number of files increases, it will be difficult for even for a single user to know where his file is present. He may not remember all the names of all the files he has got. So, searching or locating his own file will be difficult. And in the same directory, there will be files of many other users as well. So, it becomes very difficult to organize or very difficult to locate files. And the system will have more than one user, and hence all the users should be able to keep track of the files they are maintaining in this directory. Naming also becomes a problem. Say because only one directory is being used for many users, then what the name given by one user for a file should not be used by another user. Else it will be like two different users using the same name for two different files, which should not be allowed. So, naming becomes a problem. So, and even for a single user it becomes very difficult to remember names, because every file of his is kept under the same directory. So, they try to improvise this and to go for a 2-level directory. In a 2-level directory, one more level of hierarchy is given. That is, there is a master file directory, and beneath this master file directory there are a number of user file directories. So, each user here will have his own user file directory, and his files will be kept beneath this user file directory, and all these users directories will be kept beneath the master file directory. So, we have a separate directory for each user. So, because of this, what are the advantages? You can have the same file name for different users. Okay. So, it is not necessary for different users to check if the other user had given the same name for a particular file. The same file name can be used by different users. So, naming becomes easier in this case. And creation and deletion of files are confined to the user's user file directory. So, the users can't cooperate and access one another's files in this 2-level directory. So, if one user wants to access the other user's file, then they have to specify a path name, and only then they can access. Else accessing other users' files is not allowed. So, in a way there is some kind of a security, but they can use a path name to access the other users' files. So, path name will generally look something like this. It will start from the main file directory, then it will have the user file directory, and then it will have the name of the file. So, if one user has to use another user's directory, say for example, this user has to access say directory X, and within that he has to access this file X of user 4. Then he will have to specify the path as user4/x. That is how he has to use. He has to specify the master file directory, then the name of the directory beneath it, and then the name of the file. Now, another problem with this 2-level directory is that suppose there are system files like the loaders, assemblers, compilers and so on, and these system files will be needed by all the users. So, if one user is confined to use only the files within his user file directory, then where will all these system files be kept? So, will they be copied to each and every user file directory? If it is done that way, then it is going to be waste of space, because in each user file directory these files will be copied, and that will occupy too much of a space. So, what can be done is that one special user directory can be created, and that special directory can contain only the system files, and the special directory should be accessed by all the other users to get information or to use the files within that particular directory. So, they can define something called a search path. So, this search path is nothing but a path which is being used to search for files which are not kept in the current directory. So, by default the system will search for files in the current directory, and if it is not present in the current directory, then it look into the search path. So, the search path will have the path of a directory where the system can search for the other files which is not kept in the current directory. So, this kind of support is provided even in Unix and Windows, where a search path can be given, where a number of path names can be provided. So, if a file is not present in the current directory, by default the system will go and check the path names in the search path and search for files in that search path. So, this 2-level directory what we had seen just now is just like a 2-level tree. So, this was just extended to have multiple levels, and they came up with the tree structure directory. So, in tree structure directory it is the most common directory structure, and you have multiple directories at multiple levels. So, a directory is also looked at as a special kind of a file, but there is a bit to differentiate between a regular file and the directory file in the directory's contents. So, one directory can have subdirectories as well as files beneath it. So, subdirectories are directories which will be differentiated using this bit, and files will be differentiated using a different kind of type of a bit. And system calls support are provided for creating and deleting directories. So, the tree structure will have a root directory, and beneath the root directory there will be a number of subdirectories, and beneath that you can have a number of files and other subdirectories and so on. So, every file here will have a unique path name, and here users will be assigned something called a current directory or the directory in which they are currently working. So, whenever a user logs in, he will be assigned a current directory, and that will be the directory in which the file will be searched. So, whenever there is a need to access a file, the file will be searched first in the current directory. So, any process that is created by this user will use this particular directory as the current directory. And it is also possible to change the current directory of one user to another directory using system calls as well as commands. Say for example, the cd command is used to change the current directory to something else. So, cd will change the current directory to spell mail prog. So, it will change the current directory to prog. So, thereafter by default the search will happen in directory prog because that is the current directory. And when a process is created by the user, when this is the current directory, and if that process creates another child process, then the child process will inherit from the parent process the current directory. So, the same current directory as the parent process is inherited by the child process. So, it is possible to change the current directory to something else, and then if you try to list the files in the current directory, it will list the files that are present in the current directory. And now there are two different terms that I introduced called the absolute and the relative path name. So, in this context where you have a tree structure directory, if you refer to a path name starting from the root directory, then it is called an absolute path name. If you are specifying a path name which is relative to the current directory, if you start from the current directory and then specify the path name, then it is called a relative path name. Say for example, say root spell / mail is a current directory, say ptr / first is a relative path name. The absolute path name will be root spell mail ptr / first. See here beneath this directory mail, you have a subdirectory called prt, and beneath that you have this file called first. So, if you are looking at a path name starting from the root, then the absolute path name will look like root spell mail prt first. But since you are currently in directory mail, mail is the current directory, the relative path name will be just prt first because this is relative to the current directory mail. So, always when a file is newly created, it is created in the current directory. Now, what happens when you delete a file? So, deleting a file can be done using this rm command in Unix, rm followed by the name of the file to be deleted. So, generally this file name will be searched for in the current directory, and you will try to delete the file name from the current directory. And it is also possible to create a new subdirectory in the current directory. So, the command for creating a new subdirectory is mkdir in the case of Unix, followed by the directory's name. So, this will create a directory or subdirectory beneath the current directory using this particular name that is specified. So, if in the current directory is mail And if you are trying to create a new directory called count, you need to specify mkdir count. So, if beneath mail you can have a new directory called count. Now, what happens when you delete a directory? So, how can deletion be handled in this? Because when you are deleting a directory, it is possible to have a number of subdirectories beneath the current directory. They can have a number of files beneath the current directory. What will happen to those files and subdirectories? So, each kind of operating system handles this in a different manner. In some operating systems, if the current directory or the directory to be deleted is empty, then it is deleted as such. And if it is not empty, the deletion does not happen immediately. It will provide or it will ask the user to make the directory empty. So, the user will have to specifically delete the files that are kept beneath the directory, and the subdirectories also will have to be deleted, and only then it will allow the deletion of the directory. But some operating systems you can delete the directory as such, even if there are files and subdirectories beneath the directory. The files and the subdirectories along with the current directory, the directory to be deleted will be deleted. So, how do you access the files of other users when you have a tree structure directory? So, it is done by specifying path names. Path names, as we see, it can be absolute path names or relative path names, and it is also possible to change the current directory to the other users directory provided permissions are given. And it is also possible for users to define their own search path, like you can say that first search in the local directory. If it is not present, then search in a system file directory, or if it is not present, you can search in some other users directory and so on. So, the path or the sequence in which search has to happen can also be provided by users. But the problem here is that the tree structure directory does not allow the sharing of files and directories among different users. That is, one file may not be shared by different users. So, they came in for a different kind of structure called an acyclic graph directories. So, in this, here you can have shared subdirectories and files. So, here you see that this file called count is shared by this directory spell as well as by this directory called dict. So, both the directories, they are sharing the same file. So, here you see that there are two different path names for this particular file. So, this file can be accessed using the path name dict/count or using the path name spell/count. So, here sharing is allowed, and this will be helpful especially when, say, there are two people, they are working on the same project and they have a directory which contains files which need to be shared between the two different people. Then in that case, this kind of a structure will be helpful. So, this is not the same as having two different copies of the same file. It is not like that. It is the same file that is being shared between the two different users. So, this can be implemented, or this can be done by having links. Links can be hard links or soft links. Or worst case, what you can do is that you can duplicate all the information in both the sharing directories, but in that case you need to take care of the consistency. So, if there is updation done in one directory, then that should be immediately made known to the other directory as well. As I told you, in acyclic graph directories, it is possible to have two different absolute path names for the same file. So, how are deletion of shared files considered, how it is being done in acyclic graph directories? We need to remove the file when anyone is deleting it. But if you remove the file when anyone is deleting it, say if there are two links to the same file, then it will leave dangling pointers if the original file is removed. So, if the file contents are removed, but there is still a path that is pointing to that particular file, then it will result in dangling pointers. There are two types of links, as I told you, hard links and soft links. Soft links are also called as symbolic links. In Unix, this is being used, And in symbolic links, what is done is that you will have one file, one original file, and when a link is created to this original file, the link file's contents will have the path name of the original file. So, when you are trying to access this file from the link file's contents will be opened, you get the path name of the original file, and then from there you try to access the original file's path name, and thus you can access the contents of the file. So, in symbolic links, if the link file is removed, then that results in no harm because the original file is intact. But if the original file is removed and if the link file is kept, then it will result in dangling pointers because the link file will have the path name of the original file, and if you try to access the original file, it will not be present, and hence it will result in dangling pointers. The other way in which links can be maintained is hard links. In hard links, what is done? A link count is maintained. So, whenever the first time, say when the file is created, you will have the link count as 1. So, the second time when a link has been created to the original file, the link count will be incremented. So, each and every time the file is deleted, the link count will be decremented, and only when the link count comes down to 0, the file's contents will be removed. So, till then the file's contents will be preserved. So, here because it is an acyclic graph directory, there is no cycles involved in this. So, algorithms to traverse the graph are simple, but the limitations are that ensuring that there are no cycles is difficult. So, they went in for this directory called the general graph directory. So, in general graph directory, it is also possible to have cycles. But if cycles are allowed to exist in directories, there is a possibility of searching a subdirectory twice. So, because you have cycles, you just keep on searching from one directory to the parent directory, and then from the parent directory they will be linked to the subdirectory, and so on. It may result in an infinite loop. So, when you are searching in this directory, you need to limit you may need to limit the number of searches or number of directories that are accessed during each search, so that you do not get into an infinite loop. Or you can allow only links to files and not to subdirectories. So, what happens during the deletion of a file? So, it is possible to have a non-zero reference count because it is a self-referencing directory. So, then in that case, how do you remove the files? The files may not get removed at all, and the files may not get deleted at all. So, in this case, you may need to do garbage collection. So, garbage collection may need to be done, say, in periodic intervals of time. And what is done during garbage collection? The file system is traversed, and whatever file is able to be accessed, those files are allowed marked. And again, in the second pass, what is done? Again, go through the file system and collect all the files that are not marked into a list of free space. So, but this is extremely time consuming for a disk based file system. When the disk is very large, it is difficult, but it will save space, it will collect all unused space. So, acyclic graphs are easier to work with when compared to this graphs with cycles. That is what we see here, and every time a new link is added, you can use a cycle detection algorithm to determine whether it is okay in the case of acyclic graphs. So, the summary for this class is that we saw what is the structure of a disk. The disk can have partitions, volumes, and so on, and you also maintain directory structures. And directory structure, there are different types of directory structures: one level directory, two level directory, later evolved into tree structure directory, acyclic graph structure directory, and then you have a graph directory. So, we are seeing different logical structures of directories. References. Thank you.